Good afternoon. My name is Verlani. I'm a PhD candidate at the Institute of Informatics at the Federal University of Rio Grande do Sul, and I'm also a teacher at the Federal Institute of Rio Grande do Sul. This paper that I will present, entitled Integrating Reputation to Recommendation Techniques in an E-Learning Environment, is an article coming from my doctoral thesis, which I will defend soon. Professor Marcelo Pimenta, one of the authors, is my thesis supervisor. Distance learning has been increasing in many countries, including Brazil, and represents part of the students in the country's technical, professional, and higher education. The expansion of distance learning occurs due to the increasing of technologies in education. Technology has become a tool that has the power to aid the development of education in order to reduce the distance between teaching and students without losing quality in the teaching and learning process. This is a summary of what I will present. Introduction, research problem, motivation justification, related works, E-REC-REP architecture description, experiments and results, concluding remarks, and references. The education that can be offered through the Internet is called e-learning, and to support the students of distance learning, web systems called virtual learning environments or learning management systems are used. In the example, we have some environments commonly used in Brazil, like AulaNet, Teleduc, Moodle, and AdaptWeb. In virtual learning environments, learning objects can be defined as any digital entity that can be used, reused, and referenced in the learning process supported by technology. Examples of learning objects include multimedia content applications, instructional content, learning objectives, software tools, and instructional software, people, organizations, or events referenced during the process of technology to support teaching and learning. Traditional e-learning environments expose a large amount of diversity of learning objects, making it difficult to choose the objects that best meet students' needs and preferences. Students often do not have sufficient knowledge to find the material, since only the keyword search available in the object learning. The repositories are not enough for the students to find what they want. However, the choice of learning objects is very difficult due to the lack of trust that users have in relation to the available material, as well as in relation to the person who provided, as recommender, the material. Research has pointed out that people tend to rely more on recommendations from trusted people, like friends, than on recommendations based on anonymous ratings. In view of these problems, we believe that integrating reputation models into e-learning environments can improve the learning objects recommendation process. Then, our goal is to develop an architecture we call E-REC-REP that integrates reputation with recommendation in e-learning environments. Recommendation systems require the use of user behavior patterns to support and customize its recommendations. Therefore, the recommendation system uses techniques for information filtering to identify these patterns of behavior, content-based filtering and collaborative filtering. Other techniques such as knowledge-based and hybrid recommendation system can also be used. Some principles and authors used in this work. Reputation is the general opinion of one group about someone. Cruz, 2007. Concept of reputation and trust are linked. Joseng, 2006. Different techniques for calculus of reputation have been implemented with distinct results. Pujol, Sangueza, Delgado, 2002. Considerable interest in reputation systems is taken into account to evaluate user reputation and inter-user trust across social web and e-commerce applications. In addition, studies on the use of reputation models in learning environments have increased in recent years. This figure describes IREC-REP, our architecture that aims to propose reputation integration to recommendation techniques for learning objects recommendation in virtual learning environments. The main components of the model are the e-learning environment, the recommendations component, and the reputation mechanism. Next, I will detail each of the components. In the e-learning environment, we have the student model and the domain model. The student model used in this work was proposed in IRABITE and provides personal information of the student, their preferences, their profile learning, which is directly related to user preferences and technological characteristics related to student access. The domain model is structured in 4 items in the environment: concepts, exercises, examples, and supplementary materials. Among these 4 categories, we are interested in complementary materials, which is where learning objects are arranged in their different types: videos, images, sounds, text, etc. The recommendation component has the function of recommending the most appropriate learning objects for the student profile using recommendation techniques. We adopt recommendation based on user-user collaborative filtering, as it seeks to find users more similar to the active user based on their evaluations. In order to generate the recommendations, we use the Pearson coefficient or equation to evaluate the similarity of one user in relation to the others. The reputation mechanism aims to assess the reputation of the users who will recommend the material in order to improve the confidence of the recommended information. For such, there are 3 repositories available. Student repository, containing information about the student as the student's personal information, preferences, and learning profiles. Learning objects repository, containing information about the learning materials such as formats like text, image, audio, or video. Rules repository, containing the parameters that are used to calculate the reputation of a recommender. The reputation was calculated according to a metric created and adapted from the Mo-Drop model and aims to create an arithmetic average of all attributes defined for the user who will recommend the items. To measure the reputation of a recommender, some parameters were defined: their level of formation, their area of training, and their area of interest, the number of recommendations, and the evaluation related to each recommendation. The figures represent briefly the architecture implemented in Moodle, where we have in Figure 1 the environment where the student can use the Need Help button to visualize the generated recommendations. In Figure 2, we can see the list of recommendations generated, and in Figure 3, a screen that contains the reputation of the authors who recommend the material is presented. To evaluate the IREC-REP architecture, initially we selected 30 students from different stages of education, from teenagers to higher education students, being them of different ages, comprising men and women, who were already using the virtual learning environments to carry out their activities. Each participant was instructed to use the application in the virtual environment. A questionnaire was applied to the participants, with the first 5 questions concerning the ease of use and the other 5 ones concerning the perception of utility, according to Table 1. The alternatives for answering the questions were structured according to Likert scale, in a range that starts from 1, totally disagree, to 5, totally agree, indicating the participants' level of satisfaction with the application. Analyzing the results, it can be observed that the approving level is good, both for ease of use and for perception of utility. However, we found results on the partial and indifferent scale in the issues related to the number of recommendations generated and the order of presentation. This can be explained as a concern with the equality control of experiments developed in the IFRGS, depending on the issues related to the number of recommendations generated and the order of presentation. From the observations made, we can conclude that, nowadays, the use of recommendation systems and reputation models in areas such as e-commerce has become common. In our approach, the reputation is used in order to improve the confidence of the recommended information. Differently from other works, this work also includes junior researchers because of the metric adapted in this work. RecRep is being incorporated into the virtual learning environment Moodle as a plugin so that it can ideally be used in any other learning environment. The inclusion of the reputation in an e-learning environment presents itself as a differential. Initial experimental results show that our proposal had good approval. We plan to report more results in future publications. For example, to carry out other experiments aimed at improving the prototype, expanding the possibilities of use in teaching institutions. Incorporate other techniques of recommendation systems. Define other metrics for reputation calculation. Adapt the architecture for use in other e-learning environments. Here we have some references used in this work. Thank you for watching.